Hello, my name is Yash Dore, and this is the video for CS441 Homework 1. First, I will begin by showing you my AWS account over here, YDHR2. That is me. Unfortunately, I did not get to deploying this homework on AWS, so once I show deployment, I will be showing the execution on Hadoop. So here's my README. Um, we are going to skip over this part, oops, but obviously when you're reading it, don't skip over it just for this video. For the sake of time, we're going to skip it. Um, Installation instructions as well. I list potential versions you can use as well as the version I used. Some of these, it's a little bit flexible. Some of them, it is not. Make sure you have all of these installed as well as they're configured correctly, including adding pat very not adding paths to the path environmental variable. And make sure you do all of these as well. I will also skip them because I have done them already. So we'll get to running the program. We'll go over Hadoop, as I said. So first we want to start Hadoop file system and yarn. So we're going to cd to the sbin directory under our Hadoop installation. Uh, I already have it open, so I'm going to close these so I can show you how to do it. So I have it under my Hadoop. Oh, no, that was fine. Sorry. Hadoop slash, I believe it's Hadoop. Oh, sorry. Command prompt is a little bit finicky, but make sure you are running it with elevated privileges. Here I have administrator. There we go. And let us go here. Oh, sorry, mistake again. Here we go. And then go to your sbin. The path here will depend one on your OS and where you installed it. Make sure you go to the sbin directory. So now we want to do start DFS. As I mentioned here, if you're on Linux or Mac OS, you're going to want to use the shell files, but I am on Windows using command prompt, so I'm going to run these two. So that should have opened two command prompts. That is what it did. Now we're going to run start yarn.command. Here we go, two more. So in four total, including the one you have, should open five, or should if I open four of them being DFS and yarn. Don't close those. We need those. Um, and also make sure you do this once. Place the directory of PDFs on Hadoop file system. Going to skip this and this because it relates to that. I've already done it. And big, definitely look at application.conf, the configuration file to change the program to use your preferred model or input output paths. Super important. It likely really won't work unless you do that. Make sure you do this. And also this, you can read this in your own time. So now we are going to need to open Olama. You can either keep Olama desktop open or run Olama serve in a terminal. I'm going to just open Olama desktop, keep it open in the background. So now we need to build the fat jar file. So make sure you're in the project directory as I mentioned above. Oops, I'm already there. I need to open the terminal and run it. It's a little bit slow. So while it does that, I will explain a little bit. Um, I will show you the application.config. We have a couple parameters sorted into a couple different categories. So what I mentioned is that you probably want to modify this. Right now, I have put all the PDF files in this folder, and I have the text file where they're of their paths in here. Right now, I'm only running small paths only has the directory, the path to two PDFs, not all of them because it would take a long time to run all of them. So I will do this, and then this is the output directory on Hadoop file system, and then this is the number of reducers. Similarly, there are more things you can change, like for chunking, you can change these. The models, you most likely want to use these unless you are going to use the ones I have specified. And then for querying and analysis, and yeah, make sure you change those to whatever you would like. So this should be done soon enough. Um, It is going to run the tests automatically when you run or when you're creating the fat jar. But if you want to run the test separately, you can reuse this command. So it has run the test as you can see, and now it's going to build that jar file. So let us give it a few moments to do it. There we go. Okay, so as I mentioned, this README, it's going to produce the jar file under this location relative to the project, which is going to be here, target, Scala, whatever your version is, and here. So now we can run it on Hadoop file system because here, not Hadoop file system, Hadoop, because we have Hadoop running. So we are going to take this command. But because this is the relative path, you might need to change it. So I'm going to use the absolute path. I believe I have it in here. There we go. Absolute path. Make sure you're specifying the correct main class. We're going to run it. Going to pause here while that runs. I'll show you the intermediate steps while it's running the map reducer, and then I'll show you the completion. All right, we're back. Took like a minute or so, but it has started to run the MapReduce job. It'll take a couple more minutes, so I will pause here and show you the results when this is done. All right, we are back. It was pretty speedy, in fact, and it is done. You can see, fully ran it. Has a lot of interesting statistics if you want to look. You can also check the log files that I can specify the location in the README, but we'll not be going over it right now. But what we will be going over is seeing this index. Let's not remove it, but instead, let's see what is in it. I'll take a couple seconds. Yes, so because I ran it on uh, only two PDFs, we only have two shards here, but those shards show you what one contains. It essentially contains parts of the leucine index as well as something we will get to later. So now that built the leucine index, but now we want to generate the full statistics. As I mentioned, this is some intermediate file with the statistics. Not too interested in it, but we're going to run this. So you can reuse this previous command, but make sure to change the main file you are running. So we are going to run, I believe, index analysis. So that again, it is a map reduce job. Actually, no, it is not. Sorry, it is not a map reduce job, but it is still somewhat lengthy. So I will stop here and show you when it is completed. All right, we are back. As you can see, it has completed. A lot of logging, etc. Not going to really go deep into that right now, but we can see that it has written our token embeddings into that file, nearest neighbors to this file, similarity results to this file, and analogy results to this file. We will not be looking too close at them right now, but I can give a brief look. So we will show token embeddings.csv first. So that should have output. Oh, and I accidentally used ls instead of the cat command. Let me rerun it there. There we go. Essentially, as you saw, it's just a bunch of numbers. That's what embeddings are. They are nicely categorized. Like for ugly, for example, we have this embedding. And now we are going to look at a different file. Why don't I, in fact, show you index again? You can get a brief reminder. So these shards are still here. We just looked at token embeddings. Might as well look at analogy results now. Results.yaml. And you will see, oh, I did ls again. Pardon. You will see that the results are kind of weird. This is because I only ran this on 2 PDFs. So some of these words are not really the um, in this corpus of 2 PDFs, but I did account for that by putting some missing. See, for these two, generates this score, how similar. And now we're going to take a look at global stats. In each of these shards, you saw a stats CSV. This is basically that, but aggregated. Scrolled too far. Sorry. So this is basically just the token and its frequency. If I didn't mention already, this token embeddings is just the token and the embedding. Split them into separate CSV so it's nice and clean. Otherwise, it'd be like really gross to look at if you didn't want to see the embeddings, but you had to see them. So we've looked at that so we're going to look at nearest neighbors and then similarity results. Actually, I can do similarity results first. I think you autocomplete. So that will have, so this, scroll up pretty far. So this is the analogy results. You have like a word minus some other word plus another word will yield you some word. But similar results is 2 words likely to be in the document. Sometimes it's not, hence this, and then their cosine similarity. So bug and fix both there only has a cosine similarity of 0.57. Positive and clone, pretty low. You can see exception error is even higher than this or this at 0.7 approximately. And finally, we are going to look at, all right, let me just show you index again for a refresher. Oh, my bad, wrong command, ls. So we looked at analogy results first, then global and stats. Looked at similarity results just now. Looked at token embeddings before. Now we're going to look at nearest neighbors. Nope, not ls. We want cat. Autocomplete. Nearest neighbors. This, as you will see, will show each word, and it's, I think, 10 nearest neighbors is what I have right now. And I believe how similar they are. So we have, let's go to like a good example. Let's go to Java or JDK. So how similar JDK to JDT, that's similar. But JDK to Java is somehow less similar because I guess despite it having a similar semantic meaning, the letters are a little bit different. So it has this for all of them. Obviously not going to look at all of them. So that concludes the statistics. Now we are going to query. Um, my query I put, so it's configurable in here. So I'm going to ask what is Slack. This is a MapReduce job, so it is going to take a little bit of time, just like, sorry, let me move that, just like the building index, but shouldn't be as slow. So I can copy it, but obviously, again, this path might not be accurate. So I'm going to use the command I used previously. Here we go, and run, I believe it's called ask. Let me check. Ask Lucene MR driver. MR is MapReduce, if you're wondering. So that is going to run. Again, I guess I can show you the intermediate results and then the completed results. Let me do that then. All right, we're back. I actually misspoke. You have to should pass your query to um, as an argument when you're running it. The one in application.config is just a backup, but I guess the backup will never be used because my program requires you send this argument. So I input what is Slack. The MapReduce job ran quicker than the one for building the index, and it has output my the response from the LLM. So we're going to go back, leave its query result. It's because I have this here. It is going to be different for you if you change that. So um, we have this and this. It's going to be in here, I believe. So let us ls that. Oh, sorry, not ls, cat. It's going to be a cat because it is text. Let us do that real quick. Here we go. So, here is the answer. Blah, 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 blah. Um, it is, the LLM is provided with context from the corpus, because I'm only running with two PDFs. I bet that Slack itself is not in these two PDFs, though I'm pretty sure Slack is mentioned as like some sort of coding tool in some other PDF. But I assume it is not going to take anything from the context, hence it gave me just a general answer. But if you run it with all 608 PDFs, it should give you something. It should use the context to produce the answer. And yeah, that is here. We kind of went over these slowly. There's also the logs, as I mentioned earlier. You can read these in your own time. This I will do after this video. And as I mentioned, you can run Scala tests via this command. Here's a repository structure. And yeah, thank you for coming, or thank you for watching this video. I hope you enjoyed it, and I guess I won't see you next time. Or maybe I will if there is a video for homework too, which I'm excited for. All right, that is all. Bye-bye.